Okay, so you're actually back to our managerial economics class. Back to our previous lessons on production in a short run. Are you good? We our previous lesson we treated the same production in what? The short run. There's a last question we are going to treat based on production in a short run. Then we say goodbye to production in a short run. Then we move to production in the long run. So actually this question is a 2020-2021 past question on a short run. So I'll actually drop the question in a link below the page. So let me read the question. Okay. So Cyborg Breeder is a sole proprietorship specialized in the production on breeder farms. Most of the raw materials used in the production of these products are acquired in a very competitive market in Makola. In order for the CEO to maximize profits in the short run, she employed her husband, who is an economist, to estimate the demand curve for her product using data from 164 customers. The estimated demand curve for breeder farms is given as there is the estimated demand curve for the breeder, the cyborg breeder. There is the estimated demand curve. Okay, the fixed cost per unit is 125 over Q. The variable cost per unit function is this. Where Q is the number of breeder farms produced. P is price of breeder farms. Now the first question is determine the number of breeder farms that maximizes the firm's profit. I mean you are going to find for what? The output, which is the Q. So okay, so this is the first question. Determine the number of breeder farms that maximizes the firm's profit. Okay, let's come to our question. We have estimated demand curve. We have fixed cost per unit, variable cost per unit. Okay, we know that when you are being asked to find for profit, we use what? Total cost. Profit. Total cost minus, I'm coming. Profit. Total revenue minus total cost. So meaning we are supposed to find what? Our total revenue. We also find what? Our total cost. We know our total revenue is what? Price times quantity. Total cost is total fixed cost plus total variable cost. So now, let's come back to our question. We need to find for total fixed cost. Also find for what? Total variable cost before you can get the actual total cost. Now, total revenue, we need to find for price. We need to find for quantity before you're able to get what? Our total revenue. So how then are we going to get the total revenue? Okay, we are given estimated demand curve. Someone might ask that now, let's say this price times quantity. How am I going to get a price here? We get a price out of the estimated demand curve. We are going to make P the subject of the demand, we are going to make P the subject of the estimated demand curve. Are you good? Then we get a price here. So let's start. So we have that. Let's first find what our total revenue. So there's it. Total revenue, which is TR. So total revenue is price times Q. So we need to first find our P, which is the price. How then do we get a price, which is this P? We will pick our estimated demand curve and make P the subject. So there's it. So 2Q 10 minus 0.25P. So make P the subject. So we have 2Q. 10, we'll send it to the side. Or let me arrange it well. Negative 0.25%, so positive 0.25p. There's 10. There's plus when because it's negative 2Q. We have 0.25p. 10 minus 2Q. So we divide both sides by the coefficient of p. So we divide. Both sides by the coefficient coefficient of P. So now we have this 0.25P, 10 minus 2Q. So 0.25. 0.25. If we did this way, you might be marked wrong. This is a number. This is a number with a variable. So we don't divide all by the denominator, which is 0.25. Rather, we do what? We separate them. So this is wrong. So we clean this. Do it this way. 0.25. This one is 0.25. So let's see what we get. 10 divided by 0.25. This comes out. We have P is equal to this side is 40. 2 divided by 0.25. You have this side 8. There's a Q here, so this is a Q. So this becomes our price function. So now we can find for total revenue. Total revenue is price times quantity. So that's our price function. We have our Q. So total revenue. So this. Here, total revenue, price times Q. So now we have P to be this. So 40 minus 8Q. The Q out is P times Q. So don't forget to bring the Q. So there's it. There's Q. There's it. Now, total revenue. Q times 40. Q times negative 8Q. So Q times 40 give you 40Q. Negative 8Q times Q give you negative 8Q squared. So this becomes our total revenue function. Now, we are done with what? Our total revenue. We need to move on to what? Our total cost. Since we know profit is total revenue minus total cost. Now, with this total revenue, there's it. So when we are done with our total revenue, we move on to calculate or find for what's total cost. So now we know total cost. Total cost, which is TC. TC is equal to total fixed cost plus total variable cost. So let's come and check the question. Do we have total fixed cost? Do we have total variable cost? Well, let's say we have fixed cost per unit. Per unit is not the same as fixed cost. If it's fixed cost, the question is supposed to state that the fixed cost is this, the variable cost is this. But the question is using what? Per unit cost. Per unit cost is different from fixed cost. So if you are given per unit cost, meaning that with this actual figure given here is your what? Average fixed cost. Whenever you see per unit cost, it stands for what? Average fixed cost. So we know average, we have this. Average fixed cost, which is AFC. So AFC is equal average fixed cost equals total fixed cost over quantity. Now, the average fixed cost, what was given to you? What was the average fixed cost? 125 over Q. So it falls under. So 125 over Q. Total fixed cost. Okay, let's first make it a function first. So average fixed cost. We are given average fixed cost. We only want the total fixed cost. So meaning that we need to make TFC what? The subject first. Before we be able to find the what? Total fixed cost. So now we want to make TFC a subject. So we multiply through by what? Q. So AFC times Q is equal to TFC over Q times Q. So Q cancels here. This gives us AFC Q is equal to total fixed cost. So this is now what our total fixed cost formula we are going to use in order to get the actual total fixed cost we are going to use in this formula. So if you see this question and it's per unit cost, then straight away use 125 over Q, you get it wrong. Because we don't use per unit cost in the formula, we use what total fixed cost. So you need to change the formula. So now there's it. So let's check. Average fixed cost, what is given to us? 125 over Q. Remember, there's a Q here. So there's it. Is equal to total fixed cost. Q, it moves out. So now our total fixed cost is equal to 125. So now the total fixed cost is what? 125. We are here to find for what? Total variable cost. So we have total fixed cost is what? 125. So based on the formula, total fixed cost plus total variable cost. We now have our total fixed cost to 125. We are left with the total variable cost before you be able to get the actual total cost. So let's find our total variable cost. Now, check the side. There's variable cost per unit, and I told you that any per unit is referring to what? Average. So meaning that this figure is what? Average variable cost, but not what? Total variable cost. Are you good? So in order to get the total variable cost, we have to, this is our average variable cost. Average variable cost, AVC. So AVC, average variable cost, is total variable cost over quantity. Now, you are looking for total variable cost based on the formula here. This formula, total variable cost, not average variable cost. But we're giving average variable cost in the question. So if you use this average variable cost, you get it wrong. You need to find for the total variable cost. Now, so what then do we do? We need to make TVC the subject. So let's multiply through by what? Q. So AVC times Q. This TVC over Q times Q. This cancels out. We have AVC Q is equal to TVC. So now that's our total variable cost of the function. So the AVC, what was the desert? So we come and fix it here. So we have this 2Q minus 20 plus 100 over Q. Desert. Remember there is a Q outside. So desert is equal to TVC. So now let's follow. Okay, let me go this way. Desert. Now Q times 2Q will give you 2Q squared. Q times negative 20 will give you negative 20Q. Now, Q times the whole of this. Q times the whole of, so we have 100 over Q times Q. So Q cancels, so we are left with what? 100. So we come and fix 100 here, but remember it's what? Positive, so there's positive. So 100. So this becomes our what? Total variable cost. So this is your total variable cost. But not this. So but not that. This. So this is the actual total variable cost you are going to use in it. So now we have what? Total variable cost. We have total revenue. We have total first cost. Now total cost, total first cost, total variable cost. Total first cost we have 125. Total variable cost, we had an equation. So we then join it together to get what? Our actual total cost. So let's go. So total first cost was 125. So let me write it because I'm planning this side. So 125. So now total cost, total first cost, total variable cost. Total first cost was what? 125. So total cost, total first cost 125. Now, total variable cost was this. So let me put it there. 2Q. Okay, 2Q squared minus 20Q plus 100. Okay. Now you first check. Is there any variable that looks common here? Or do we have actual numbers here? Then you add them, then you get the actual total cost. We have 2Q squared. We have Q. Q squared is never, or it's not the same as Q. So let's bring back our 2Q squared. So this is our 2Q squared. Now, this is not the same as this, remember. So let's bring back our negative 20Q. So negative 20Q. Now we have same numbers, 1, 2, 5, yes, they are all numbers. There is no variable attached to it, so we can add them. So 125 plus 100, let's add it. 125 plus 100. Oh, we get 225. So now 125 plus 100 is giving us 225. So plus 225. So this is our actual total cost. So total cost function. 40 minus 8Q. Total revenue 40Q minus 8Q squared. Total cost 2Q squared minus 20Q plus 225. What we had earlier on is what I've just written here. So it's the same thing. So now we need to get our profit function. So profit Profit function. So profit is equal to total revenue minus profit function is what? Total revenue minus total cost. So what was our total revenue we had? We had this. So total revenue 40 kilo minus 8 kilo squared. Total there's a minus our total cost function 2 kilo squared minus 20 kilo plus 225. Now remember there's a negative here. This is total revenue. The whole of this is total cost. Remember there's negatives here. You just bring your bracket. Now let's solve it. 40 kilo minus 8 kilo squared. Negative 1 times 2 kilo squared, negative 2 kilo squared. Negate 4, 20 kilo. Negate 4, negate 225. Now let's group like this 8 kilo squared. This negative 2 kilo squared. So negative 8 kilo squared plus negative 2 kilo squared will give what? Negative 10 kilo squared. So we have this. Negative 10 kilo squared. Now there's 40 kilo, there's 20 kilo. They are the same kilo. So 40 kilo plus 20 kilo give us plus 60 kilo minus 225. So this becomes our profit function. So this. Now we are asked to determine the number of breakdown funds. So we are going to pick this profit function and differentiate this profit function with respect to kilo for us to get the number of breakdown funds, which is the I. So now, this is where we use the first order condition and the second order condition. I go. So first order condition FOC. The first order condition states that for any maximum or minimum point, the profit, the Q, should be equal to 0. So we have this. The turning A is the same as for any. That's how we call it in accounts. This the turning A is called for any. So for any maximum or minimum point, the profit over the Q is equal to 0. So we are going to equate this profit function to 0. So we have the profit over the Q. So we have minus 10 Q squared plus 60 Q minus 225 is equal to 0. Now, based on our understanding in indices, whenever you are having an exponent like this, we bring this in front and subtract 1. So there's it. Xn. That's how we do it. The k is constant, so we maintain the k. The n, we bring it in front of the x. So there's it. You bring back your x. Now the n, subtract 1. That's how we do it. So this idea is what we are going to use here. So let me maintain it. Let's see how we do it. So we have this. The profit over the q. Now, based on here, this side, we'll bring it in front, meaning that negative 10 is constant. So there's negative 10. There's the 2. Q, 2 minus 1. So it's the same thing here. Let me plan it. So when you are differentiating with respect to a variable, meaning 1 minus 1 is what? 0. So you only have 60 here. Differentiating with respect to a constant is 0. So we don't bring this figure. So it's equal to 0. So now we have negative 10 times 2 give you, let me use the power. In order not to confuse myself, 10 times 2, we get 20. So negative 20 Q. If you subtract 1 from 2, you get 1. So we don't write a 1 there. So plus 60 is equal to 0. Now, we want Q. So we make Q the surface. So we will send the Q to the right hand side, becoming positive. So you have 60 is equal to 20Q. We divide both sides by the coefficient of Q. Side by the coefficient of Q. So now we have 60 is equal to 20Q. So 20. So Q is equal to 20 cancels 60. 2, 1 goes here 3. So we have 3. So now the I determine the number of beta funds. That's maximizing the first profit. So we have So the number of breeder funds that's going to maximize the profit is what 3. But then you can't justify your answer based on your first order condition. It might be wrong. That's the main reason why when you are done using the first order condition, you then prove this figure whether it's correct by using what? The second order condition. Are you good? So let me go and see. So second order condition, which is SOC. With the second order condition, the square profit over the Q square. Let's have that. With the second order condition, we are going to differentiate this. Not the one being equated, not this. Not this, the 60 is equal to 20 Q, no. The actual one, which is this, negative 20 Q plus 60 is equal to 0. Not 60 is equal to 20 Q, but what? Negative 20 Q plus 60. So, negative 20 Q plus 60. Okay. So now, we are going to differentiate the second order condition. We are going to differentiate this. Are you going to respect to what Q? So what then do we do? This is how we do it. Negative 20 Q. So we have 1 minus 1 is 0. So we have what? Negative 20. Constant, it comes with 0. Are you good? So now it's less than 0. So with the second order condition, it says that when your answer is less than 0, you are going to maximize profit. If your figure or your number is greater than 0, then it's what? A minimum what? Profit or minimized profit. So negative 20 is less than 0. So therefore, the quantity 3 units is going to what? Maximize profit. So therefore, the quantity in is going to maximize profit for the breeder funds. So now we are done with the I. Determine the number of breeder funds that maximize the firm's profit. So it's scale, right? Then use the second order condition to prove this figure, what you have here. So the second order condition, we differentiate this, but not the one you equated, the actual one. So this, we are going to still differentiate respect to what? Scale. So there's only Q. So 1 minus 1 is what? 0. So negative 20. Constant becomes 0. So it's less than 0. Are you okay? So now when it's less than 0, maximum profit. If it's greater than 0, minimize profit. That's it. Let me see. This. Maximum profit. So there's the less than 0, maximum profit, greater than 0, minimum profit. So we move on to the next question. The second one, how much should the firm charge for a unit of breeder fund? How much price? How much should the firm charge for a unit of breeder fund? So we're just asking for what price. Remember that we differentiated the estimated demand curve to get our price. So the price function we had was, so the price function we had P is equal to 40 minus 8Q. Now, we want to get a price. We just solve for what? Quantity, which is Q, to be what? 3. So when Q is 3, so we have P is equal to 40 minus 8. Q is 3. So P is equal to 40 minus 8 times 3. 8 times 3. 24. So now 40 minus 24, we have 16. Now, therefore, the firm is going going to charge a price of 16 cents for without funds. The third one is what? Find the total profit at the profit maximizing level of output. So with this side, we'll bring back our profit function, what we had. So our profit function. So we had our profit function to be 60 kilo minus 10 kilo squared minus 225. Now we're asked to find the total profit. Remember, we already solved for kilo. So we just come and input the kilo here. Then we get the total profit. So when kilo is 3. So profit 60. 3 minus 10. 3 squared minus 225. So 60 times 3, you get 180. Minus 10 into brackets 3 squared. You get minus 90 minus 225. You get profit to 180. 180 minus 90 minus 225. You get minus 135. So find the total profit at the profit maximizing level of output. We had our profit to negative 135. Someone might say that I know profit, I can't earn what? A negative profit. We have negative profit. A negative profit is the same as what? Abnormal profit. So with this one, the firm is enjoying an abnormal profit. Okay, so find the total profit at the profit maximizing level. So there's the total profit, negative 135. So basically with this question was actually last year's past question, 2020, 2021. So there's the end there. So we say goodbye to production in a short run. So we then move to our next one, which is what? Production in the long run.